Good morning. We just try to understand this topic, derivative of the function. Derivative of the function means we need to understand this concept of derivation only. Concept of derivation. So, first, what we do, we understand what is the derivative of the function. So before going for derivative of the function, we have to understand about function. The function must be a continuous function. What is the meaning of the continuous function? Suppose you are having a function. If you draw the graph of that function, you are getting this graph like suppose like this and this. So what you find here, while drawing this graph, we are not lifting the pen. We are not taking one pen up from paper. That is why this is a continuous graph. Suppose you draw the graph. While drawing the graph, you put it like this and open the pen and you draw like this. So there is a break in the line. There may be the possibility this will go this side and this will go this side. So there must be a break. If there is a break, that means this is called continuous function. So what you understand means the meaning of this continuous function. The meaning of this continuous function, if you take the value of this graph at this particular x, for this particular x, it will give you two different values. For this x, it will give you does not exist. For this case, it will give you either it will be does not exist. There may be the possibility it is a continuous function, but it is existing. Suppose one function is going like this, and at this point, it is not here. It is coming here, and this is a defined function. Suppose this is the point x. So x is equal to a. At a, it is defined as -5. Rest it is moving like this. Again, it is moving from this point like this or this, whatever it is. So when you go for this, you find at a, the value of function is different. And at a plus something, the value of function is different. And 8 minus the value of function may be different. So what I mean to say, there may be the possibility these two values are same, but this value will exempt this value and this will be different from these two values. So in this case, situation, we tell the given function is discontinuous, not continuous. I hope it is clear. So whenever we talk about continuous function, then only we talk about differentiation. The function which is not continuous, that is not differentiable. About this differentiability and continuity, you have to read further in class 12. This is not the part of this time for class 11th. So it will take a longer time because this is a vast chapter, continuity and differentiability. Basically, differentiability means total differentiation. So we will discuss these all things in class 12. But for this class, we will discuss finding the derivative of the given function or many functions with the basic principle, that is called first principle. So before that, what we understand, what is the derivative? So first condition is that fx is a given continuous function. This is the first condition. What is the meaning of this? This meaning of this, there is a fx and the value of fx is basically y. What is this fx? Fx is a function of x and that is denoted by y. That means this y become your independent variable and this x is given in this fx, that is called independent variable. So y is dependent and x will be independent variable. So here y will depend on the value of x. If x changes a lot, y will change according to that. So if you change x very small or you make a very small change in x, that means value of y may change very small. So in case of derivative, we just discussed about that thought only. What happens if you change you make a very small change in x, then what will be the value of a change in the value of y? That is what we read in this derivative. So basically what we see here, we take a little increment in y for the corresponding increment in x. So whenever we go for a very small change, that is denoted in mathematics by this symbol. This is called delta. So this x and we have added in this delta x. So if you add x in delta x, your value of y got changed as y plus delta y. So what I mean to say, we can say if y is equal to fx, if y is equal to fx, then y plus delta y will be equal to f x plus fx, delta x, sorry, f plus x plus delta x. So again, once again, what is the meaning of this? We are changing x very small. That means we are adding very fine part, very fine number in x, and for that very fine corresponding value of kx, we are finding corresponding part of corresponding value of y, and that corresponding value of y will be denoted as y plus delta y. So what is the change here? The change is very small. That means this change will be intending to zero only. This change will be intending to zero only. Wherever it will be required, we will go for changing for very small, or delta x will be going to or tending to zero only. I hope it is clear. Now what I do, you get here two functions. One function was earlier function that was given to you, that was like 1 minute. So now we have got here function like so what we do, we so here what we do, we take we have taken one function as y plus y is equal to fx, and another function we have taken as y plus delta x for the value of x plus delta x, corresponding value of x plus delta x. So that is what we have to go here. So what we do here in this condition, what I have to find? I have to find the change in y in correspondence to x. That is why what we do, we subtract one function from another. So in this situation, what do you find? Delta y will be equal to function of x plus delta x minus function of x. Now what I do? What we are doing? We are finding the change in y with respect to x. With respect to x, that is why we are dividing this by delta x, both sides. Once you divide both sides delta x, then what I do? We take the limit of delta x tending to 0, because we have changed x very small. So this is called limit of delta y by delta x, where delta x is going to be 0 or tending to be 0. And this is defined in mathematics as dy by dx. So this is taken as dy by dx. So our formula become here, delta y dy by dx is equal to limit of x plus delta x minus fx divided by delta x with the limit delta x tending to 0. I hope it is clear. So now we proceed further. So this become our formula. And wherever we will get this condition to find any differentiation, we use directly this formula only. Dy by dx is equal to limit of dy by delta y divided by, for delta x is tending to 0, and is equal to limit of function of x plus delta x minus fx divided divided by delta x. So this is called differentiation of y. Differentiation of y. Now condition is that, or motto of this chapter is that we have to find the derivative of at a point. Derivative at a point. So this is called as f dash. We denote as f dash x at any particular value of x. Suppose x is taken, suppose what I am taking. Suppose I am taking one graph is here like this, and this is the point A. At this point, if you find the dy by dx of this, and you put the value of x as a, or independent variable as a, whatever the value you get of dy by dx, that is called differentiation at a point. This is denoted by like this only. Here we put x is equal to a. In this way, we can write it dy by dx. I hope it is clear. Now, sometimes what happens? Sometimes differentiation of a function may be existing, may not be existed. So we have to check whether it is existing or not. Wherever the function is not continuous, there may be the probability it will not be. There may be not. This will be. This must non-differentiable. Must be non-differentiable. So if fx exists at that particular point, then only we tell fx is differentiable at a. Otherwise, it is not possible. So now we proceed further, and in this section we will discuss about some questions also, how to find differentiate by first principle. So that means how to start. Yeah, one more thing here. That is geometrical significance of the derivative. So whenever you take a curve of any function, that is a continuous function. At that any particular point, when you draw the tangent, at this point, the slope of the tangent is called dy by dx. Slope of the tangent is called dy by dx at that particular point. So that means what we have to find? We find here dy by dx, and for the value of a, and that will be told slope of the function. So this is the geometrical representation or significance of derivative. So for any curve at any point, if you draw the tangent, you will get the slope same as the dy by dx at that particular point, or derivative at the particular point. So now we go here for a differentiation from the first principle. So for if you go for a differentiation from first principle, so in starting we just take the first example as x to the power n, and we go for that differentiation only. So what we do in this situation? In this situation, we just write let y is equal to x to the power n. So we take y is equal to x to the power n. So we write here first. Therefore, what will be there? Change y plus delta y. Here we will write let y is incremented by delta y be an increment of y, in y corresponding to increment in x as delta x. So it will be x plus delta x to the power n. So now what I do? We take this as first function, first equation. This is a second equation, and we just subtract from one another. If you subtract from one another, you will get it like delta y is equal to x plus delta x to the power n minus x to the power n. Now what we find? What we do? We divide both the side by delta x. We divide it delta x. Now what I do? We give the limit of delta x is tending to 0. So we write here limit delta x is tending to 0, because this is very fine chain. So we write the both sides the same thing, limit delta x is tending to 0. So this will be now called dy by dx. So we write it as dy by dx. Now we solve it. So can we write this function like x plus delta x to the power? So what we do, there is a two way. We just open this bracket. When you open the bracket, you will get it like x to the power n plus n into x to the power n minus 1 into delta x plus n into n minus 1 by 2 x to the power n minus 2 into delta x square. So dot 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 will be there, and minus x to the power n. So what happened? This minus x to the power n, this minus x to the power n will be cancelled, and below delta x is already given. Below delta x is already given. Now we proceed further, and we take this function like this. We can write it as dy by dx is equal to limit. And what I do, what you find here, delta x will be in each and every term. So we take delta x common. So here you will get n into x to the power n minus 1 into 1 plus n into n minus 1 divided by 2 into x to the power n minus 2 into delta x, because one delta x I have taken out like that, and divided by delta x. Now what you find, delta x will be cancelled. This delta x will be cancelled, and here it is telling delta x is tending to 0. Now what we find, you got this as a polynomial function, and we know for polynomial function we just substitute the value of variable to find the limit, or limit for finding the limit value we just put this value here. So if you put it, you will get it as n into x to the power n minus 1. So this is dy by dx, dy by dx for what, where y is given x to the power n, so we can write it as x to the power n, differentiation of x to the power n by dx, yeah, differentiation of x to the power n is equal to n x to the power n minus 1. So this is our first formula. So now we go for another. So before that, what we do, we take one more value. So I am first changing the screen. So we go for this. We go for blank page. So here what we do, we delete this all part first, then we proceed. 1 minute. Actually, I'm doing this recording first time on Zoom. That is why I am facing issue. So anyway, so we go for now. So this is the way we find the differentiation of x to the power n. Now we take some more thing, like suppose we take a differentiation of sin x. Suppose I have to find differentiation of sin x. So for that, what we do, we take y is equal to sin x. So what will be the value of y plus delta y? This will be simply sin x plus delta x. This is not my issue. This is the way we go. So this is your first equation, and this will be your second equation. So what we do now, we subtract second from first from second, or second from first. So in this situation, you will get delta y is equal to sin x plus delta x minus sin x. Now we break this using formula sin c minus sin d. So what is the formula? That is 2 cos c plus d by 2. So when you take c plus d by 2, it will be x plus delta x by 2 into sin delta x by 2. Okay. Now what I do? We divide both side by lambda x, sorry, delta x, and we put the limit delta x is tending to 0. So it will be now delta y by delta x, where limit is taken as delta x tending to 0. So now what we get? We get it as limit delta x is tending to 0 to cos x plus delta x by 2 into sin delta x by 2, and this whole will be divided by delta x. Now what happens? If you put the value of delta x, you will get it as a cos x. But what about it? We get it undeterminate form. This is 0, this is 0, 0 by 0. So for this, what we do? We proceed further. So we write here one more sentence. We use the thought of limit. simply. So it will be like limit delta x is tending to 0, and I will give this to cos delta x by 2, x plus delta x by 2 into 2 into sine delta x by 2 and divided by delta x. And we know one rule, limit if you take of sine x, limit of sine x by x, where x is tending to 0, then only it is 1. So whatever the angle is here in radian, that will be here. So what we do, we make this equal. So for making this equal, what we do, we divide by 2 and we multiply by 2 in the denominator. So now what happened, you got one function like that, and this become value become 1, and this 2 will be cancelled now. So in this situation, you will get, now what we do, we just put the value of delta x. So you will get it as cos x plus 0. So this become cos x into 1, which is equal to cos x only. That is why differentiation of sin x is cos x. Now we have to remember this. Dx to the power n is equal to n x to the power n minus 1 by dx is it is always. So now I will not write in the denominator dx. You will understand this. So d sin x is equal to cos x. Similarly, if you find d cos x, it will be minus sin x. Similarly, if you find d tan x, it will be sec square x. If you take d cot x, then you will get minus cosec square x. If you find d sec x, then you will find it as sec x into tan x. If you take d cosec x, you will get it as cosec x into cot x, but it is in negative. Other than this, we have some more formula. Dax plus b to the power n. In this situation, what we do, we take this coefficient out. So it will be a into, and this n will be also there. So n ax plus b to the power n. We will read this as chain rule further. Now we go for d 1 by x. So 1 by x is taken as x to the power minus 1. So it will be x to the power minus 1. So for this, what will be the formula? We use the same formula as we are using here. So for this, so it becomes like minus 1 into x to the power minus 1 minus 1. So it becomes minus 1 x to the power minus 2. That can be written as also minus 1 by x square. Okay. One more formula is there, that is the exponential function d e to the power x, that is equal to same e to the power x. If any coefficient will be there, that will be repeated as coefficient of whole function. So I hope now as battery is low and I am not in condition